In our previous topic, we have discussed the how the interference pattern forms for a uniform thickness of the film. So today's class, I would like to explain you if the thickness of the film is varies, how the interference pattern we will discuss. That is Newton's rings. To explain this concept, I would like to take a plano convex lens. Plano convex lens means one of the surface is plane surface and another surface is curved surface. This is called plano convex lens, whose focal length is very large. I want to be place this one on a plain glass plate. This is a plain glass plate. This is a plain glass plate. Whenever I keep this plano convex lens on a plain glass plate, at the center both are in contact. There the thickness of the air is 0. From the center, if you go towards radially, the gap between the lower surface of the plano convex lens and upper surface of the plain glass plate increasing. In between these two, air will exist. This film is called as air film. The thickness of the air film from the center, if we go towards the end of the plano convex lens, increases. Now our concept is how the interference pattern exists, this type of patterns. To study that one, we have to consider a monochromatic source of light whose wavelength is lambda. So these are the rays coming from the source. These are the rays coming from the source. We have to be placed one glass plate with 45 degrees angle. This is another glass plate. We have to be inclined with 45 degrees angle. Whenever we have placed this one, the rays are coming from the source and incident on this glass plate, and some of the part will be transmitted and some of the part will be participated in the reflection. The reflected beam reaches our plano convex lens. Once again, here some of the part will be participate in the reflection and some of the part will be participate in the transmission or refraction. The refracted beam reaches our thin film here. Once again, here some of the part will be participate in the reflection and some of the part will be participate in the transmission. Again, the transmitted beam reaches the upper surface of the plain glass plate. That is also a lower surface of this air film. Okay. Here also some of the part will be participate in the transmission and some of the part will be participate in the reflection. Now, the rays reflected from the upper surface of the air film and lower surface of the air film will participate in the interference. These two are coming from the same source. So these are coherent sources. When the coherent sources are participating in the superposition, the interference observed. To observe this interference pattern, we have to be placed a microscope above the 45 degrees inclined glass plate. If you observe there, what we can observe is at the center we can observe a dark spot. From the center we can observe a successive alternate bright and dark rings. A successive alternate bright and dark rings like this. Why the rings are circular? Why we can observe the dark spot at the center in a reflected system? In a reflected system, why we can observe at the center dark spot? Why? Okay, next. How the separation between the two successive rings is varies. When we move from the center to the end. How the rings are radius is depends upon the radius of curvature of plane of convex lens. How the wavelength is depends upon the radius of the ring. These are all I will explain you based on some mathematical expressions. Okay, so first of all, we have to be recall that why the rings are bright. Some of the rings are bright and some of the rings are dark. Why? Because the bright rings are due to the constructive interference. The dark rings are due to the destructive interference. The bright rings are due to the constructive interference and the dark rings are due to the destructive interference. Why the rings are circular? Why the rings are circular means, for example, it is a plain glass plate. On this, if we place the planar convex lens like this, so at the center both are in contact. Yes, we agree. Okay, suppose from the center some x distance or r distance, if you take, okay, the gap between the lower surface of the planar convex lens and the upper surface of the planar convex lens r, that is our thickness t. So if you observe from the center, if it's the distance of r in the surrounding, totally the thickness is same. For example, if that r distance is satisfying the condition constructive interference from the center throughout the circle, that will satisfy the constructive interference only. Due to the constructive interference, we will get the maximum intensity. Maximum intensity means brightness. So all these bright spots can forms like a ring. That was explained by Newton's. That's why the concept is named as Newton's rings. So same like that, if we take some x distance from the center, if we take x distance, if that particular point is satisfying the destructive interference, the surrounding x distance, all the points is also satisfying the destructive interference only. Due to the destructive interference, darkness, that means intensity will be zero. All these zero intensities will forms like a ring. That's why the dark rings are formed. Now, next point we have to be discuss is why at the center we are observing the dark spot. Next, how the radius of the ring is depends upon the wavelength of the source of the light and radius of curvature of given plane of convex lens. To understand that one, we have to be take this total extension of plane of convex lens. So plane of convex lens, how it came? Suppose if we take a sphere, so this is a sphere. This is a sphere. From this sphere, we are taking as a small arc. Small arc. So this small arc, this is a small arc. Okay, this arc, that means it is a plane surface and also it is a curved surface. Okay, so like this, we are getting this planar convex lens, whose center is, I am saying here, so C, and it is placed on a plain glass plate. It is placed on a plain glass plate. Okay, so we have to take whose radius of curvature, that is also I am saying here r. How much I am saying? R. This is the r, that means this is the radius. Okay, this is the center point O and it is named as E and it is named as E dash. E dash or O dash. Okay, now we have to take some point within the distance of R. This is the distance of R. This is the R. This is the R. Where the thickness of the film is, T. The thickness of the film is T. This point I am saying H and this point I am saying P. Now we have to be prove why at the center we can observe the dark spot. Regarding that, we have to calculate the path difference. So what is the path difference here is the path difference according to the Stokes formula. According to the Stokes formula. So for example, it is also I am saying R. This is R. Okay, the rays are incidenting here and reflecting, and another ray participating in the interference is traveling t distance and reflection takes place. That means another t plus t, that is 2t plus 2t plus. There is a additional path reference we have to be considered, that is lambda by 2, that is 2t plus lambda by 2. This is the path difference of the waves participated in the interference. For example, at the center, if we see at the center, if we see the thickness of the air film is t equals to 0. Therefore, path difference equals to how much? T equals to 0. That means lambda by 2. As we know that when the path reference is lambda by 2, 3 lambda by 2, 5 lambda by 2, like that, destructive interference takes place. Due to the destructive interference, we can observe the zero intensity. Okay, that is the first. This is called as equation number 1. Okay, so at the center we observe the dark spot. Okay, now our aim is to be derive the relation between the radius of the ring and also the wavelength of the source of the light. Regarding that, we have to be equate this path reference condition to our general conditions, that is constructive interference condition and also the destructive interference condition. For the constructive interference, we are observing the bright rings. Due to the destructive interference, we are observing the dark rings. Now, for a bright ring, if you want to get bright ring, so for bright ring, what we want? The path reference must be equals to the integral multiple of wavelength. The path reference must be equals to the integral multiple of wavelength. That means that should be equal to the n lambda. But according to our theory, what we got? The path reference is 2t plus lambda by 2, that equals to n lambda. T plus n lambda. 2t plus n lambda by 2 equals to 2t plus lambda by 2 equals to n lambda. That implies 2t equals to lambda by 2 minus 2t plus lambda by 2, 2t equals to n lambda minus lambda by 2. That implies 2t equals to 2n minus 1 into lambda by 2. If you do the multiplication, 2n into lambda by 2, 2 cancel, n lambda minus 1 into lambda by 2. This is called equation number 2. Okay, so same like that for the dark ring. So the dark ring happens when destructive interference takes place. So for the destructive interference, path reference condition is so 2n plus 1 into lambda by 2 or 2n minus 1 into lambda by 2. Here we have to take 2n plus 1 into lambda by 2. So as per our first equation, that is equals to the 2t plus lambda by 2. Therefore, if we equate those two, 2t plus lambda by 2 equals to 2n into lambda by 2 plus 1 into lambda by 2. 2 cancel. Lambda by 2 cancel. So, therefore, 2t equals to n lambda. This is called as equation number 3. So, these are the thicknesses of the dark ring and also the bright ring in terms of wavelength, and also n is the integer. These are also called as order or number of the ring. Number of the ring. Now we have to calculate this one. That means how it is depends upon the radius of curvature. Regarding that one, from the arc formula, from the when this is called as one chord. This is one chord and this is another chord. When two chords are intersect, according to the mathematical formula, according to mathematics or formula of circle, when two chords are intersect, how we can write is HE into EP. HE into EP equals to OE into EO dash. OE into EO dash. HE. This is also equals to the radius. That means R into R equals to OE, which is equals to the thickness of the film, that is T into EO dash. EO dash value we don't know. Okay, EO dash value we don't know. So regarding that, we have to be take the total one. That means OO dash. From the OO dash, if we subtract this OE, we will get the EO dash. That equals to T into OO dash. OO dash is the diameter. R is the radius. So diameter means 2R. 2R minus OE. OE means T. Okay. Now we have to be take that one. That is, if we do like that, R into R square equals to T into 2R. 2RT minus T into T square. T square. Here T square is negligible. Why? Because T is the thickness of the air film. Okay, that is in the decimal value. If we do the decimal values to the square, those will be becomes very minute. That means small. That's why we have to be neglect this T square. Okay, T square is very small. That's why I have to be neglect. That implies R square equals to 2RT. That implies 2T equals to R square by R. This is called as equation number 4. To get the radius of the bright ring and also the dark ring, we have to substitute this fourth equation in second equation and also the third equation. Okay, shall we? So just you have to be remember this equation 2t. Instead of 2t, we have to be substitute R square by R. Okay. For bright ring radius. So how we got 2t equals to from equation 2 2t equals to 2n minus 1 into lambda by 2. From equation 2 2t equals to 2n minus 1 into 2n minus 1 into lambda by 2 that equals to R square by R. that implies r square equals to, if we do the 2t 2n minus 1 into r lambda, 2n minus 1 into r lambda by 2, that implies r equals to square root of 2n minus 1 into r, 2n minus 1 into r, 2n minus 1 into 2n minus 1 into r by 2, where for the nth ring, where n is the integer, it indicates that, suppose if you want to calculate the radius of the first bright ring, n equals to 1, you have to be substituted. N equals to 1, you have to be substituted. If you want to calculate the radius of the second bright ring, you have to be substituted n equals to 2, like that. Okay, from this equation we can say the radius of the ring is, all are in numerators. The radius of the ring is directly proportional to the square root of the number of the ring. Radius of the ring is directly proportional to the square root of the radius of curvature of given plano convex lens. The radius of the ring is directly proportional to the square root of the wavelength of the source of the light. Now we have to calculate the radius of the dark ring. To calculate the radius of the dark ring, we have to be for dark ring. For the dark ring, the 2t which is equals to the r square by r. That means r square by r equals to, according to that equation, that is path reference equals to the n lambda. That is equals to the path reference n lambda. That implies r square equals to nr lambda. That implies r equals to square root of nr lambda. That means the radius of the dark ring, here also have to be put small n. N gives the number of the dark ring. So Rn equals to, that means radius of the dark ring equals to, is directly proportional to the square root of the number of the ring, square root of the radius of the curvature of the given plano convex lens, and radius of the ring is directly proportional to the square root of the wavelength of the source of the light. By using this equation or formula, these two are very important formulas. Calculation of bright ring radius and calculation of radius of the dark ring. Okay, from in your examinations you will get the problems based on these formulas. By using this one, I would like to conclude the, if we, from the center, if we go towards the end, the separation between the rings is decreasing. We will prove that one based on this one. Okay. Now we have to calculate the radius of first dark ring. Radius of first dark ring. That means n equals to 1. That means n equals to 1. So when n equals to 1, r1 equals to square root of 1 r lambda. That equals to square root of r lambda. For second dark ring, n equals to 2, r2 equals to square root of 2r lambda. That is square root of 2r lambda. Next, then for a third dark ring, first we have to calculate the separation between the second dark ring to the first dark ring. R2 minus R1. That implies square root of 2R lambda minus square root of R lambda. That equals to, from these two we can take it as a common, that is square root of R lambda. If we take as a common root 2 minus 1. Therefore, second ring and first ring, the separation distance equals to root 2 minus 1.414 minus 1 square root of r lambda. That implies r2 minus r1 equals to 0.414 square root of r lambda. This is 0 point. So same like that, we have to take for the third dark ring, for radius of the third dark ring, third dark ring, third dark ring, and also a fourth dark ring. So n equals to 3. N equals to 3 means radius of the third dark ring r3 equals to 3r lambda. For fourth dark ring, for the fourth dark ring, n equals to 4, r4 equals to square root of 4r lambda. We have to be observe the separation between third and fourth dark ring. So if we take r4 minus r3, r4 minus r3, that equals to square root of 4r lambda minus square root of 3r lambda. That implies r4 minus r3 equals to root 4 minus root 3 into root r lambda. Root r lambda. Okay. r4 minus r3 equals to root 4 minus 2 and 1.73. 73 for something. So 73. Therefore, r4 minus r3 equals to 2 minus 1.73 to 0.27 square root of r lambda. That means if we take from the center, that is thickness of the air film is 0, that's why in the reflected system we are observing a dark spot. From that, if we observe, we are observing a concentric beautiful rings. These rings are demonstrated by Newton's, that's why those are called as Newton's rings. Now this separation between these rings, either maybe dark rings or bright rings, these are decreasing. If the number of the ring is increases, that means radius is also increases. So automatically the rings should be very close proximity. Why? Because r2 minus r1 is 0.4, but r4 minus r3 is 0.27. So if we go, automatically the intensity will be decreases. Okay, this is the Newton's rings concept. Thank you.